4 buns I don't need. So I am removing the superfluous buns.
I'm sorry, sir, but you're going to have to pay for all 12 buns. They're not marked individually.
Yeah. You want to know why? Because some big shot over at the Wiener Company got together with some big shot over at the Bun Company and decided to rip off the American public. Because they think the American public is a bunch of trusting nitwits who'll pay for things they don't need rather than make us stink. Well, they're not ripping off this nitwit anymore because I'm not paying for one more thing I don't need. George Banks is saying no.
Who's George Banks?
Me!
Okay, so now you saw that it's kind of crazy. If you've been to the store and you happen to notice this strange thing, hot dogs come in packs of 10 and buns come in packs of 8. So the question is, what's the least number of packs that you should buy in order to have the same number of hot dogs and buns, right? You can't go to the store and just take out a few of the buns and say, I don't want to buy them. Okay, so here we go. So I'm thinking dogs come in packs of 10, right? So I just skip count by tens, right? 1 pack, 2 packs, 3 packs, 4 packs. And then if I look at the buns, they come in packs of 8. So I've got 8, 16, 24, 32, 40. So what I need to do is I need to buy 40 hot dogs and 40 buns. But the question is, how many packs do we need? So if we look at this, this is 1, 2, 3, 4 packs. This is 1, 2, 3, 4, 5 packs. So the idea is I need 4 packs of the hot dogs and I need 5 packs of the buns, and then I will have 1 hot dog per bun. Okay, let's look at one last example. You'll see questions in the textbook that ask you for error analysis, and you're being asked to describe and correct the error in finding the least common multiple. Oops, I do have one more example after this. Okay, so notice that this student said, hey, I can do the least common multiple just by multiplying the 2 numbers together. Okay, so my approach to these, where I'm trying to correct somebody else's error, is I try to do the work correctly myself, and then I compare them. So if you want to make a list of multiples, right, you can. 6, 12, 18, 24, 30, 36, and I'm going to get up to 54 because that's what they did. Where am I? 42, 48, and then the next one is 54. Okay, now when I start with the 9s, I go 9, 18, 27, 36, 45, 54. Okay, so cool. 54 is a common multiple, right? But wait a minute, so is 36. But wait again, so is 18. So the least common multiple is 18 because I want the smallest multiple in the list. So the person had the right idea. You definitely can multiply the 2 numbers together to get a multiple. But the least common is 18. So I would say they found a multiple, but not the least, right? But not the smallest. They found a multiple, but not the smallest. That's the error that they made. And then to correct it, I write that the LCM equals 18. That's how you describe and correct the error. Okay, let's look at one last one where I'm trying to figure out if these are always, sometimes, or never true. And so the first question states, the first statement says the least common multiple of 2 prime numbers, 2 different prime numbers, is their product. And I think that makes sense because if you think about it, they have no common factors. And what do you do if there's no common factors? You multiply the 2 numbers together. Okay, that's going to be always true. Now I have the least common multiple of a set of numbers. You guys haven't even worked with a set of numbers. I'm going to show you. Like if I do 5 and 10, that's a set of numbers. It's just a set of 2 numbers. But I'm saying these are the only 2 numbers you can use. Okay, the least common multiple of a set of numbers is equal to one of the numbers in the set. Okay, so what's the least common multiple between 5 and 10? Well, It is 10, and it is in the set. So that actually worked, right? Like, I think it's true. But then I want to see, I wonder if there's a time when it's ever not true. So what if I pick, I'm looking at my prime numbers. I like to use those a lot because it makes my life easy. What if I use 2 and 3? What's the least common multiple with 2 and 3? Well, it's 2 times 3, which is 6. So the least common multiple of 2 and 3 is 6. So now, is 6 equal to, does it match one of the numbers that I started with in my set? No. So this time, it was a big fat no. One time was yes, one time was no, which means it's going to be sometimes. Okay, so there's an always sometimes. We can try to guess that the next one's going to be a never, but let's figure it out. The greatest common factor of two different numbers is the least common multiple of the numbers. Wait, what? That doesn't even make sense. How can the greatest common factor be the same as the multiple? Okay, I don't know. So here's what I'm going to do. I'm going to pick the greatest common factor. I'm going to use my prime numbers of 2 and 3. They're prime, so the GCF is 1. That's the only number they have in common. But I know the multiple is 2 times 3, which is 6. 1 is not the same as 6, right? I think we're going to run into this problem every time. Because remember, factors are smaller and multiples are bigger. Let's just try one more. Let's try 3 and 11. They have no common factors, so the greatest common factor of 3 and 11 is 1. But the least common multiple is 3 times 11, which is 33. Okay, so we can see that's never going to be true. All right, that's it. Have a great day.